On December 19th, scientists around the world will be doing something extraordinary. They'll be coordinating observations of a single object using over 20 different spacecraft and dozens of ground-based telescopes simultaneously. NASA, ESA, and space agencies worldwide are treating this like a planetary defense drill. Except there's no threat. So why the obsession? Why the unprecedented global response? Because what's arriving on December 19th is something we may only see once in a generation. And if we miss this chance to study it, we might never get another. This is 3I Atlas, and it's about to reveal secrets that will change how we understand the universe. Let me put this in perspective. In all of recorded human history, we have confirmed exactly 3 interstellar objects passing through our solar system. In 2017, ʻOumuamua shocked the world, a cigar-shaped object that tumbled through our system and vanished before we could properly study it. In 2019, 2I/Borisov gave us more time, but it was faint and distant. Now, in 2025, we have 3I Atlas, and this one is different. This one is close enough, bright enough, and active enough that for the first time in history, we can conduct a comprehensive, multi-wavelength, solar system-wide study of an interstellar visitor. Every major observatory has been tasked with collecting data. Hubble captured detailed images of its nucleus and coma. James Webb analyzed its chemical composition in infrared. Mars Reconnaissance Orbiter got the closest look when the comet passed just 19 million miles from Mars in October. MAVEN detected its hydrogen emissions. Lucy, Psyche, and Europa Clipper spacecraft scattered across the solar system all turned to catch a glimpse. This is coordination on a scale never before attempted for a comet, and it's all happening right now. Here's why scientists are so obsessed. 3I Atlas is showing us chemistry that doesn't match our solar system at all. James Webb's infrared spectrograph revealed the comet's coma is dominated by carbon dioxide, with a CO2 to water ratio of about 8:1. In our comets, water dominates. Carbon dioxide is secondary. But 3I Atlas flips that ratio. Why? Because it formed in a different stellar environment, around a different star, with different temperatures, different available materials, different formation timelines. The comet is also releasing carbon monoxide, carbonyl sulfide, water vapor, cyanide gas, and here's the really weird part: atomic nickel and iron vapor. Metals vaporizing off the surface. The nickel to iron ratio is unusually high, suggesting chemical processes we've never observed in solar system comets. This tells us something profound. Planetary systems around other stars don't all follow the same rules. The building blocks vary, the chemistry varies, and 3I Atlas is our first detailed look at what that alien chemistry actually looks like. Now here's an embarrassing admission. We don't know how big 3I Atlas is, and that's driving scientists crazy. Hubble observations estimate the nucleus is somewhere between 1,400 feet and 3.5 miles across. That's an enormous range. You could fit 12 football fields inside the small estimate, or an entire mountain range inside the large one. Why can't we pin it down? Because the comet is surrounded by a massive coma, a cloud of gas and dust that obscures the solid nucleus. The coma measures over 11,000 miles across and is constantly changing as jets erupt. Trying to measure the nucleus through all that material is like trying to measure a grain of sand inside a sandstorm. But size matters. It tells us about the comet's mass, which affects how gravitational interactions shaped it. It tells us about surface area, which affects how much material can outgas. And it tells us whether 3I Atlas is typical of interstellar objects or an outlier. In October, ESA's ExoMars Trace Gas Orbiter did something incredible. By observing 3I Atlas from Mars' orbit and triangulating its position with Earth-based observations, they improved the comet's predicted location by a factor of 10. This is huge, because predicting where a fast-moving, outgassing object will be weeks in advance is incredibly difficult. The jets pushing it off course create uncertainties. By using spacecraft at 2 different points in the solar system, Earth and Mars, scientists could nail down its trajectory with unprecedented precision. This technique is being hailed as a proof of concept for planetary defense. If a dangerous asteroid were heading our way, this is how we'd track it. 3I Atlas is the perfect test case, fast, unpredictable, and requiring rapid coordination between multiple space agencies. The fact that it worked so well is genuinely exciting for future planetary security. After December 19th, 3I Atlas will continue moving away from Earth. It'll pass near Jupiter in March 2026, giving us one more observation opportunity, then exit the solar system forever. By spring 2026, it'll be too faint for most telescopes. The observation window is closing, and that's why December is so critical. Right now, the comet is still bright enough, close enough, and active enough to study in detail. Citizen astronomers with backyard telescopes are contributing observations to global databases. Professional observatories are dedicating telescope time, usually reserved for other projects. NASA is releasing new images and data almost daily. Because everyone in the astronomy community understands, we will never get this chance again. No human alive today will ever see 3I Atlas return. It's a one-time visitor on a one-way trip through our solar system. Here's the most exciting part. 3I Atlas is a rehearsal. ESA's Comet Interceptor mission, scheduled for the 2030s, is being designed specifically to intercept interstellar objects. The plan is to park a spacecraft at a gravitationally stable point in space and wait for the next ʻOumuamua, the next Borisov, the next Atlas. When an interstellar visitor is detected, Comet Interceptor will launch, intercept it, and collect samples. Direct samples. Material from another star system, analyzed in detail, potentially returned to Earth. The data we're collecting from 3I Atlas right now is informing the design of that mission. Scientists are learning what instruments they'll need, what challenges they'll face, what kind of chemical signatures to look for. In a very real sense, 3I Atlas is teaching us how to hunt interstellar objects, and the next time one arrives, we'll be ready to catch it. December 19th isn't just a date on a calendar. It's the culmination of months of unprecedented global scientific collaboration. It's the moment when an ancient traveler from another star system passes closest to our world, carrying secrets from a planetary system that may no longer even exist. And it's our one chance, our only chance, to decode those secrets before the comet vanishes back into the cosmic darkness from which it came. So pay attention, because moments like this don't come often, and the knowledge we gain from 3I Atlas will echo through astronomy for generations. This is why scientists are obsessed. This is why December 19th matters. And this is why you should be watching.